Hello students, in the last lecture I was discussing about optical detectors in the instrumentation device subject, that is your in the advanced instrumentation subject. I was discussing the topic optical detectors, and in the optical detectors topic I was discussing about the prerequisites that you need to know for the complete understanding of this subject. And lastly I discussed about the threshold wavelength, and I told you what is the formula after putting the constant values in its original formula. It is lambda is equal to 1.24 into 10 to the power 6 divided by EW, where EW is the work function. So let's take an example so that you will get to know the usage of this formula better. So suppose the numerical is like this. Suppose determine the threshold wavelength in the case of cesium surface for which the work function is 1.8 electron volt. So it is given here, that is the surface, it is given here. The work function of the surface is also given here, and we are asked about the threshold wavelength which is required by this surface for the electron to come out from this surface. So the formula, as we know, the formula is lambda naught is equal to 1.24 into 10 to the power 6 divided by EW. We have given the value of EW in the question, so we will be putting the value of EW and we'll calculate it. What is the value of EW? It is 1.8 electron volt. So we'll put the value of EW in the formula and we'll get the threshold wavelength to be equal to 689 nanometer. So you are supposed to practice more questions on this formula. So I'll move ahead with another topic, or you can say another prerequisite that you need to know for the optical detectors topic. So the next term you need to know is lumen. So what is lumen? Lumen basically it is the basic unit of power in photometric systems. So what is photometry? Photometry basically it is related with the measurement of light within the visible band with respect to the response of human eye. So it is the measurement of light within visible band, photometry. So what is lumen? Lumen is the basic unit of power in photometric systems. It is also called luminous flux or luminous power, or you can say it is defined as the rate of luminous energy emitted from a source. So here I've shown a diagram. So what is lumen? To better define lumen, what is lumen? Suppose a point source. So if a point source of one candela, now you might be wondering what is point source. So point source is a source. So basically point source, it emits light uniformly in all directions. Any source which emits lights uniformly in all directions is called the point source. So here this is a point source of one candela. Now I'll tell you one candela later. So first you understand this, that when a point source of one candela, it is placed at the center of a perfectly transparent sphere. This is a perfectly transparent sphere. The radius of the sphere is 1 meter, and at the center of this perfectly transparent sphere whose radius is 1 meter, at the center of this sphere a point source of one candela is placed. Now then the light passing through one steradian, this is steradian, this angle is steradian. So what is steradian? Basically, as you know, in measuring plane angle we use the unit radian. Radian is the unit for the measurement of plane angle. In the same way, steradian, STERADIAN, steradian is the unit for measuring solid angle. Now since this is a sphere, obviously the angle will be solid. So what I was telling you, this is a transparent sphere of 1 meter radius, and at the center of this transparent sphere a point source of one candela is placed, and the light which is passing through one steradian, this angle is steradian, the light which is passing through one steradian or an area of 1 meter square, this is the area of 1 meter square located on the surface of this sphere, is called lumen. So this is what lumen is, or in very short you can say it is the rate of luminous energy emitted from a source. Now the symbol that we use for lumen is Lm. Lm. And the notation for luminous flux, you will see the notation for luminous flux is phi. Now next term is luminous intensity. There you will get to know what is candela. Now as I've told you, what is lumen, that is the amount of light that is coming out from this one one steradian angle. So the amount of light that is passing through this one steradian is lumen. And what is luminous intensity? It is the measure of luminous flux per unit solid angle from a point source. The unit of luminous intensity is lumen per steradian. Lumen per steradian. And the SI unit of luminous intensity is candela. So candela, basically it is the basic unit of luminous intensity or flux per unit solid angle. Next term is luminous terrence. It is the measure of photoelectric brightness, or it is defined as the luminous flux per unit area emitted from a light source. Luminous flux per unit area emitted from a light source, and the unit of this luminous terrence is candela per meter square. Candela per meter square. That is luminous intensity, or you can say luminous flux per unit area. So luminous terrence was previously called as luminance. Luminance. So these were the prerequisites that you needed to know for understanding optical detectors. So in my next lecture I'll be starting with the optical detectors. How many types of optical detectors are there? So I'm ending this class here. Thank you.